homework question, in case you attempted, I attempted. Does anybody have the solution? So, I did it quickly and I didn't check that it's correct. So if anybody's solution is identical to mine, then I shall assume that it's correct. And otherwise, we'll need to find an error. Is this? Can anybody confirm? Can you please pick a copy of each of them? Thank you. Or has nobody done it? I won't wait for objections if no one's done it. Have you? No. Why am I even trying? Okay, so this is what I got, and this is what I got. So in the second case, the constraint changed so that the original basis became infeasible, so you had to do a dual pivot, which you're not allowed to do, of course, because you see something negative in the right-hand side. Then you follow this row until you find all the negative elements in this row. And then you do the pivot on that group. Okay, so since no one seems to have done it, then it's not make sense to dwell on it much longer. So for some reason, I created this column of homework marks. We'll see how it goes. Okay, so now to start, well, so today what the plan is to do another one of those post-optimality things, namely how to add a new constraint that wasn't in the original formulation. But before we get there, I've been too lazy to talk. I've given you this exercise here. Okay, so that's somewhere in your handout, I think. I hope. Did you take one? So now you've got about 10 minutes to solve this, and I can sleep for a bit, and then we'll check the answers. And yeah, so you can happily talk to your neighbor to remind yourself how it works, or read this section 6.2, introducing a new decision variable, and yeah, and I'll come back. Now I'll be entertaining the viewers.
Hi.
If you don't know how to do part B, then you can skip part B. You can't keep skipping part B forever because it. I was thinking of putting part B on the exam. Part B, you can skip part B if you don't want.
Is it just substituting 10 into x1, so we 2 times 10, which is 20%, and that's the objective?
No.
Okay.
I'll show you. It's a bit hard, so probably don't know.
I'll just watch his video.
It's hard to make. You're direction following down the stairs. I mean, she's just like, you know, I said, I think she was like, well, my car's she's like, oh, some days. My car's been hot. I mean, I'll just go right. That's also the next question that
It's the key.
I mean, how do you?
Okay, I'm getting bored. Just keep working. I'll be writing things, and don't mind me at all.
Yeah, I think it's I mean, I can leave.
No. Should be doing part C and not copying that word for part C.
It's a bit late.
On the one. Let's define or something.
Yeah, but the part have you found the error in the? Okay, I'm getting bored, so let's have a look at the. So, first of all, you realise that on almost everything in the tableau stays the same, right? That's what we learned last week. Now, if everything in the tableau is supposed to stay the same, then in particular, these shouldn't be, the minuses shouldn't be there. Sorry. It's the remainders of times long gone. Yeah, so these minuses shouldn't be there. All because it's an error. So how does this go? We have a new decision variable, and we know that we only need this column. So what we do is look at the coefficients in the two constraints. So in the first constraint, the coefficient is 1, because there's 1x4 less than or equal to 30. Yeah. So we'll do 1 times this column. And in the second constraint, it's 2. So we'll do 2 times this column. And when we do 1 times 1 plus 2 times -1, we get a -1, and that puts it here. And here we'll get 2. Now this one is a bit trickier, because here we get 1 times 0 plus 2 times 2. But we have to subtract the 5 that's in the objective coefficient. So this is the C4. Okay. If we do that, we get a -1. Does that make sense to everyone? Yeah, this is how it works, because this is how it always works. Okay, so that's it. Why does it say after pivoting? Because you've got -1 here. So where do you want to pivot? X1, X1, X4. Okay, this is the pivot element. So the new basis is, everybody can do that. I know. So this is just divided by, so this is easy now. 5, 1/2, 2, -1/2, 1. I'm getting bored. And here, 25. Is that correct? I don't think you should trust me as much as I do. What am I doing?
What?
Should be 25. How do you know? Should be the same. No, it shouldn't. No, nothing. Okay, the crucial step is the first one, which is how do you create the tableau from the original formulation that you have and this little bit, which is the inverse matrix in the corner. Yeah. And that's what you should know really well. because all the exercises are about that. And the way, yeah, and the way you do it is clear. Okay. Any questions about this part C? Part A is straightforward, but part B is perhaps not, because we've never done anything like that before, really. But you should remember that every row in the tableau corresponds to an equation in this system. Okay. So the equation in the objective row is, well, you can imagine that there should be another basic variable z, which is a 1 in the objective row and 0 everywhere else. So this gives you the this equation, the 20 equals x2 plus x3 plus 2x2 plus z. And every feasible solution satisfies this equation. From this equation, you know that every feasible solution satisfies, well, I'm just putting all the other variables on the other side. The 20, now because this can be 0 or positive, x2, x3, and x2, in any feasible solution, this whole expression can't be more than 20. Because it's 20, take away something non-negative. So this is never more than 20, so in no feasible solution can the objective value be more than 20, and so if you find one where the value is 20, it has to be optimal. Is that clear? Good. So that answers that question. So much for new decision variables for the moment. The next thing that we want to look at is introducing a new constraint. Okay, well, I can't remember what I'm going to do. Okay, so we're back in the chess set problem, and now suppose that for some reason, I won't be inventing really. There's something in the book, like you're running out of something. It turns out that you want to add a constraint. So you want to add the constraint x1 plus 2x2 is less than or equal to 90. And you want to see what happens without pivoting from the start. That's the key thing. Okay, it might look a bit silly to do it without pivoting from the start in an example where there are 3 constraints or 4 constraints and 2 decision variables. But if you get a huge linear programming problem with hundreds of thousands of decision variables, which do occur in practice, and you don't want to do the whole pivoting that took you, I don't know, 5 minutes. Okay. So what you want to do is add the new constraint into the tableau and get and see what happens. So in some sense, if you only want to add one constraint like this, then before you even start doing something, you should probably check whether the optimal solution that you have satisfies that constraint. Because if it does satisfy that constraint, you don't have to do anything. It's still the optimal solution. Adding a constraint can't improve your solution. So here, if you plug in x1 16, x2 46 into this, you get 108. So it's not satisfied. And if it was, you could just say, okay, the optimal solution stays the same. If it's not, then, well, there are a couple of things you could do, but perhaps the easiest and simplest thing that you could do is just, okay, so first of all, you'll have one more constraint, so you'll need one more variable in the basis. There are always as many. In the standard example, standard LP, where everything is less than or equal to, there are always as many variables in the basis as there are constraints. And if you have 4 constraints instead of 3, you have four variables in the basis instead of 3. So, so need to add a variable to the basis. And the simplest thing that you can do is where you take the basis, the original S1, X2, X1, and the new slack variable S4, because obviously there's constraint on the slack variable as well. And the new constraint with slack is what? Like this. Now you could do what you could do is calculate the new inverse matrix, because you know what ND is, and do the inverse matrix and put it into the tableau and so on. What is perhaps simpler than that is to it won't fit like that. It's to just add it to the tableau. So you don't change anything. You add the new slack variable. You don't change anything anywhere. Oh, I'm making too many errors. It's good that I still keep this as you requested last year. So what am I doing? 1/3. Okay, I've not done anything, have I? So when you think of the way each of these, both the top tableau and this bottom one, each of the rows is an equation. I've got the exact same equations everywhere because I've added a 0. So the equations that were satisfied up there are down there. Now what I want to add into the S4 row is that one. Okay, so I just simply edit by saying 90. Okay, 1x1, 2x2, no S1, no S2, no S3, and 1 S4. Now what's the problem? What is the problem? Yeah, so you're suggesting that this would be the optimal solution? Okay, we've just seen that it can't be because the solution doesn't satisfy this constraint. So there is a problem somewhere, but where is it? Yeah. If basic variables aren't basic, that's a way to put it, yes. So it's not a simplex tableau because it doesn't satisfy the properties of a simplex tableau. It is a tableau of some sort. It does express some simultaneous equations, but it's not a simplex tableau because x1 should only have one 1, and x2, and x2 should only have one 1, and 0, and this 2 again. So it's not a simplex tableau, but also it's kind of evident what one should do. Not. Yes, exactly. You can do a row reduction, just get rid of the 1 and 2, like you do with 15. So, starting from here. Okay, not a simplex tableau. Too many non-zeros in basic columns. Do reduction. Ready? What did you get? Minus 1/3. Is that right? I don't know, it could be. I'll check. Yeah. That's a row reduction. So what's next? What's it called? Dual pivot. Yes. You need to do a dual pivot. What is your pivot element?
-4 S3.
S2 or S3? Okay, let's have a vote. Who is for S2? 3.5. Who's for S3? Okay. Why is it? Why would you go for S3?
No, go for the smallest.
Go for the smallest whatever it is. Yeah, okay, so it's going to be in this row, of course. You need to pick between the two negative elements, yes? And then you do the ratios.
Yeah.
The ratio, this divided by that is 5. Well, absolute values. And here is 20, and you take the least ratio. The least ratio is 5. So it's S2. So this is the pivot element, and I don't want to bore you with doing the actual pivot. You can do it yourself if you want. But important question: what would happen if you'd taken S3 rather than S2? What happens if you don't do the ratios right and you take S3 as the variable to enter the basis? Yeah, why? Why is it going to take longer? No message. Well, in a way, yes. So what would happen is that you get a negative entry down here. So the ratio test, I keep saying that, its purpose is to make sure that you don't lose the all non-negative. Just like in the primal pivot, the ratio test is there to make sure that you don't get negative value. So in this case, you'd lose the optimal property, dual feasibility. So you'd have to pivot then to get that. But if you pivot on that element, I've done it, and it's in the book handout, so you can see what you get. And yeah, this is adding a new constraint. That was the fun for today. Any questions about dual pivoting? Sorry, dual pivoting. Yeah, not dual pivoting. I mean, any questions about adding a new constraint? We've got another adding a new constraint exercise in there next week. But in your own interest, look at it, solve it, bring it back, give me the register back, and yeah, I'll see you on, when is it, Thursday?